My name is Nurul binti Mahussin. I'm a first-year student from School of Physics, majoring in pure physics. My role is as a video editor.
Assalamualaikum and hi, my name is Nurul Irdina binti Norol Azhar. I'm from School of Physics. I'm first-year student majoring in metaphysics and my position is presenter.
Assalamualaikum and hi, my name is Farah Farisa binti Norol. I'm from School of Physics. I'm a first-year student majoring in medical physics and my role is scriptwriter.
What is electrostatic precipitator? Have you heard about it anywhere? No worries, let's go deep to know exactly what is this device. A device that uses an electric charge to remove specific impurities, either solid particles or liquid droplets from air or other gases in small stakes and other fluids is known as an electrostatic precipitator, which is known as ESP. The precipitators works by directing energy directly at the particulate matter being collected, obstructing the passage of gases only slightly. Electrostatic precipitators, which were originally meant to recover valuable industrial process materials, are now used for air pollution control, particularly for eliminating dangerous particulate matter from waste gases at the industrial sites and power plants. Such particulates, if released into the atmosphere, can limit visibility, contribute to climate change, and cause major health concerns in humans, including lung damage and bronchitis. M. Hoffel, a Leipzig math teacher, was the first to explain the precipitation of smoke particles by electricity in 1824, following experiment by American chemist Frederick Cottrell at the University of California. The first commercially effective technique was published in 1908. Early units were used to remove sulfuric acid mist and lead oxide fumes generated during acid production and smelting. How does it work? Well, it's a very simple process actually. It is made up of two electrode sets, positive and negative. The negative electrodes are wire meshes, while the positive electrodes are plates. These electrodes are arranged vertically and alternate with one another. The air stream goes through the stack of plates after passing horizontally via the spaces between the wires. Between the wire and the plate, a negative voltage of several thousand volts is applied. An electric corona discharge ionizes the air near the electrodes, which then ionize the particles in the air stream if the applied voltage is high enough. For your information, corona discharge, also called the coronal effect, is an electrical discharge created by the ionization of a fluid, such as air, around an electrically charged conductor. The free ions and electrons in the air will experience a force when an electric field is produced in the air between two conductors. Ions and free electrons are accelerated and move in the opposite direction as a result of this phenomenon. But at how electrostatic precipitators works, as the electrodes become ionized from the corona effect, a large number of free electrons contact with the gas dust particles, making them negatively charged. Due to gravitational attraction, these particles gravitate towards positive electrodes and fall off on the collector plate. As it passes through the electrostatic precipitators and into the atmosphere through the chimney, the flue gas is free of dust particles. The collector particles may be removed from the collector plates as dry material, or they can be washed from the plates with water. For sure, electrostatic precipitator has their own advantages and disadvantages. The advantages of electrostatic precipitator are the high efficiency of removal particles, which is greater than 99.9% and can achieve emission levels of less than 10 mg per nm3. It also has very low pressure drop of less than 20 mm water column. Fine particles, those smaller than 2.5 microns in diameter, can be captured by electrostatic precipitators, which are extremely harmful if discharged, since they can be pulled deep into the lungs and cause inflammatory reactions. They can also remove solid particles or liquid droplets from large amounts of gas at varying temperatures and flow rates. Electrostatic precipitators come in variety of size and types with varying dust and water droplet properties and gas volume flows in mind. Some are made to work with gases that have specific temperature and moisture characteristics. Dry electrostatic precipitators remove pollutants from smoke and dust by operating above the dew point of the gas stream. Wet electrostatic precipitators, on the other hand, work with saturated air streams with a 100% relative humidity level. In industrial settings, wet precipitators are widely used to remove liquid droplets such as oil, resin, tar, and sulfuric acid mist from gas stream. They are used in situations where the gases are humidified, contain flammable particulates, or have sticky particles. Electrostatic precipitators also has low operating costs, and in the long run, they are economically feasible. While the disadvantages of electrostatic precipitators are it has a large initial capital cost, making it prohibitively expensive for small business. Purchase and installation are both costly. In addition, to be costly, they need a lot of capacity to set up. Small-scale industries' value proposition is decreased once again because they are costly and require a lot of area to set up. Other than that, electrostatic precipitators are inflexible in their operation. It is difficult to adjust the ESP capacity or relocate it once it has been installed. As a result, careful planning is required for the capacity, kind, and location of the ESP installation. Another major disadvantage is only dry and wet pollutants, not gases. Pollutants can be collected with an electrostatic precipitator. Overall, because of its low pressure draw operation and excellent particle collection efficiency, electrostatic precipitation is a common air filtering technology. Because they can function at high temperatures and handle high speed gas velocities, they are commonly employed in industrial facilities. However, in order to achieve the optimum results, electrostatic precipitators must be designed properly. Geometric design, particle qualities such as resistivity and diameter, and environmental circumstances are some of the most important factors that determine electrostatic precipitators' collection effectiveness.